geography. And so I just want you to know a few things as to why all of these lines are here, and it might make a little bit more sense. And it does matter as far as geology goes and the earth goes and earth science and all that other stuff, and it might help you to understand a few little things as to what's going on. So I have this orange line right there. Do you know what that orange line is? No. It's called the plane. We did talk about this once. Plane of, when we talked about astronomy, when we talked about the solar system. Plane of ecliptic. Thank you. The plane of ecliptic. Now, what is the plane of ecliptic? Okay, plane. What's a plane? The plane, the plane. You know, what's the plane? Big flat piece of whatever, right? Like a tablet. All right, so with this in mind then, yay, I'm going to draw a plane. Yay, it's a plane. Anybody remember this at all? Thank you, Quaid. The plane is where all of the planets roll around on. It's almost like if we had a great big fabric and we were pulling it tight like a trampoline, and we put the little balls on there and had them go around and around and around. That is the plane, and the plane of ecliptic is the pathway where the planets go. So if the center of this, sorry you can't see this over here, but if I had the sun, it's halfway through that plane. And then I could put all the other planets on there. So I'd have one like right here, and then right here, 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 here. And this is where the planets roll around the sun. These are their orbits. And they all sit on the same plane, or also known as the plane of ecliptic. Good. We gotta make the sound effects on that, so that makes it better. This is the plane of ecliptic, and this is the point that if you were able to take an arrow and like and shoot that sucker straight, it would go through all of the planets except for one, Pluto. It wouldn't go through Pluto because Pluto is on its own plane. So it goes like this way, and all of us go this way. So it's like, wow, that's weird. So it's going around this way, but all the rest of them do. And we want the plane of ecliptic because we have to have some kind of reference as to make all of these other lines work. How much is the Earth tilted? 23.5. Okay, good. So it's tilted right here, 23.5 degrees, right? But how do we know it's 23.5 degrees? No. I just told you. What's our foundation? What's our base? Plane of what? Very good. You see this right here? Plane of ecliptic, 90 degrees. Right there. That's 23.5 degrees based off of that plane of ecliptic. Very good. Which means what would be the rest of it? 23.5 minus 90, right? Okay. Very good. I guess. I don't know. I'm just guessing. Can you see where this plane of ecliptic actually kind of comes into play here? It helps us to be able to determine our planet's orientation in space, but it also helps us to orient all the other planets and how they're tilted and moving and everything else, because we can look at the plane, and since all these planets are all on that same plane, we can base all the planets off of one thing, which is that plane, and so we can make all of those correct assumptions about those planets and how they're oriented based off of that plane. And so this is how we know that Uranus goes this way and the Earth goes this way, and because we have a reference point, which is that plane of ecliptic. So the Earth is tilted 23.5 degrees. Okay? The plane of ecliptic is where the sun is. So right here is the most direct amount of sunlight. It's coming in this direction right here. Right. And as we go around the sun ends up over here. And you see that orange line? The sun never deviates from that orange line, ever. Ever. If you could walk on that orange line across the globe, the sun would always be over your head all year long. So, yeah, you'd have to move fairly fast. But you see this? Here's the Earth. And it's tilted that way. What do you notice about that line? It's horizontal, and this is tilted 23. That's the plane of ecliptic, guys. It slices it right in half. And as the sun's going as well, we're going around the sun. So if I was the sun, okay, the Earth is pointing this way, and then it rotates and goes this way. Does the Earth do this? No, it stays in one place, right? Totally always stays in that orientation. It just goes around the sun like this. And if I was to look right here, okay, it would always be flat. So now, this is winter for us, because we're northern hemisphere is pointing away from the sun. And then it comes right over here. This is spring, okay? And then this is summer, because now we're pointing towards it, and then, yep, fall, and this is all it does. It takes 1 year to do all that. But the Earth never changes its orientation. It's always pointed in that direction. So sometimes people think that the Earth is doing this. Like, oh, yep, it turns and it goes back and it turns. Heck no. Well, that would be really pretty screwy. We'd be like, did you feel that? It doesn't. It just stays in one place and just goes around and around and around and around. But we get this real big optical illusion if you look at the sun. Like right now, if you watch the sun is really low in the southern hemisphere. And you're going to see that it's going to slowly start going higher and higher and higher. That's because, dun dun dun, right here, and the sun is starting to, what? Go up. Okay. From our perspective, it looks like the sun is moving up and down. And this is how we see it. What do you notice about that line now? Yeah, it's going up and down. It's wavy. So to us, we're sitting here doing this, and it looks like the sun's moving up and down. But it's not. We're not even moving up and down. Everything is just our orientation and how we are pointing. And so, yeah, that line goes different. So that is the plane of ecliptic. If you were to walk on that line all the way around in 1 year and kept the sun right above your head, it would always be above your head. It will never change. So now comes these other couple of lines here. Do you know what line that's called? Cancer. Cancer, right? How do you know if that's Cancer and that one's Capricorn? Doesn't these... Anybody have a hard time remembering that? I do. I mean... That's good. Here's how I remember it. So Cancer is always on top. They both start with a CA, right? CA, Cancer, Capricorn. But the next one is a P, and the next one is an N. N to me means north. So it's always in the northern hemisphere. Those of you who have your geography ever get tested on this stuff now, you know. Cancer. Tropic of Cancer, and this is the Tropic of Capricorn. Why do we even have those? There's two reasons, and you're right. There are two reasons. So one thing is if you're on that line, that's where the sun always is. When the sun is directly right here, that would happen to be our first day of summer, which is June 21st, depending if it's a leap year or not. Okay? Yep, this year it's the 22nd. It's a leap year. Yay, leap year. So excited. Okay, what if it's over here? What day is that when the sun is right there? Same, right? Except it's December. Okay, or 22nd, depending if it's a leap year or not, right? Okay, got it. And what about right here? When the sun is directly right there. This would be spring and autumn, so this is September. And that would be fall, right, or autumn. This is winter, winter solstice. This is summer solstice. And this is, what day? January, February, March. March 21st. You're right. Okay, that's spring. So why do we have these things? Why do we care? Well, we used to not have them, but back in the day, see, now you have your phones that follow you around. GPS. It's kind of weird. You know, you can like Google Map somebody. You can actually see where they are in the building. Like, oh, I know where you are. You know, like, why are you at the toy section at Walmart? That's what my kids would always ask my wife. I was like, why are you at the Christmas time anyway? Why are you at the toy section at Walmart? Can't tell you. You know, being Santa Claus. Yes, errands. Okay, well, so if it was June 21st and you were on a ship and sailing around, you should know, if you're a sailor, that the sun should be directly over this point right here around June 21st, somewhere around there. So you're keeping track of the calendar, you're keeping track of the days. But how do you know you are right here? How do you know you're not right here, or here, or here, or here? Yeah. Well, if it's June 21st, then you know the sun is directly right here. So at noon, where the sun should be directly overhead, let's say that you're right here, you don't know you're right there, but you sight in the sun at that point right through here, and then you take the angle, and once you take that angle, you should be able to determine how far you are from point A to point B. And now you know where your location is on the Earth.
The moon.
Moon is moving all the time. You got to have something that's going to be stationary. What'd you say?
It's not going to be useful for anything.
The sun is not useful, but they know where the sun's location is, or where it should be at night. And guess what?
They use
It is in the constellation Cancer. So at nighttime, if they could find the constellation Cancer, they know that during the day, at noon, that's where the sun should be. So at nighttime, they can actually make measurements from the constellation Cancer to where they are and get some angles and be able to actually guide themselves at night to figure out where they are on the globe. Can you guess why this one's called the Tropic of Capricorn? At nighttime, the Tropic of Capricorn, its constellation, is found right here where the sun would be. So at nighttime, they can actually look at the Tropic of Capricorn and identify where their location is, because that's where the sun should be in the winter time. Yeah, we don't do that anymore because your phone does it for you automatically, right? You look, pull out your phone, where am I, and it tells you exactly where you are. Okay, Tropic Cancer, Tropic Capricorn, it's important for us because it tells us where our summer solstice and our winter solstice is. When the sun is right here, this is our winter, or this is our spring and fall equinox. Nox means night, equal. That just means that every day, everybody on that line has exactly 24 hours of daylight, and 12 hours of daylight, 12 hours of night. Every day. So if the sun is shining over there in this northern hemisphere, then this side over here is all in darkness. If you look at the distance right here, that is a lot shorter than over here, which means that our northern hemisphere receives more sunlight in the summertime than in the southern hemisphere, and our days are long and our nights are short. What angle is, what latitude is the is Cancer? No. If this is the equator, this is the Tropic of Cancer, Tropic of Capricorn. This is 90 degrees. So what's that angle right there? 23.5. So where is the Tropic of Cancer? Where's the Tropic of Capricorn?